Now looking at question C, where it says point B minus 1 and 6 lies on L. This is the line that is perpendicular to this line AC. ABCD is a rhombus. Now, just a few points about a rhombus. A rhombus is like a square that's been pushed over. So it's got 4 equal sides, but the angles don't have to be 90 degrees, but all four sides are equal. They're also parallel. Opposite sides are parallel to each other, like that. And the important thing with a rhombus is that the diagonals bisect each other, and they also cross at 90 degrees. So that's an important fact to know about a rhombus. So we want to find the coordinates of point D. Now I've drawn a diagram of this here. So if we just go across, I've drawn the diagram up here where I've got point B, this one over here. So these would be two sides of the rhombus like that, and we want to find the other side. Now in this, usually when we write it, this would be A, B, C. We would expect D to be somewhere in this region over here. And because we know that it's at 90 degrees, it would be on that line. Now also we know that it's of equal length, so these lengths here would be equal, like that, as well as all of these lengths here. So I think it's quite obvious that you can see that is your midpoint over here. You're going up 2, and then you're going across 1, so you'll go down, you'll go across 1, it would be that point over there, would be point D. It would be the coordinates of 1 and 2, and so you would have something like that, and that would be your rhombus. Okay. Alright, so going back to our examples here. Question 9, it says use your graphics calculator to find the point of intersection of these lines. Now I'm not going to do this. This is pretty straightforward. You're just going to put this in. With this one over here, just make sure that you put it in the form y is equal to. So you've got 7x plus 2y is equal to 12. So you're going to get 2y is equal to minus 7x plus 12. You're going to divide by 2, so it's minus 7 over 2x plus 6. And then you will plot that. Where the two intersect will be the solution that would solve those two equations. Going on to question 10. Which of these 4 pairs of lines meet at just one point, no point, at an infinite number of points? So we've got to look at each one here. Now in looking at them, let's just put them in the form y is equal to mx plus c each one, and then we'll be able to compare them. So we would say for this one, for the first here, this is not really a line, because this is I wouldn't really know what to do with this one over here, because there's no equal sign. That's not an actual equation there. So I'm going to leave that one out. But looking at this over here, for question 2, we've got y minus 3 over x minus 1 is equal to 6. So we're going to get y minus 3 is equal to 6 x minus 1. We just cross multiply. So y minus 3 is equal to 6x minus 6. Y, we take it minus 3 over to the other side, it becomes plus 3, is 6x minus 3. So that's the one equation there. For the other one here, we've got y is equal to 6x minus 3. So it's exactly the same. So we'd expect them to be an infinite number of points, because they actually lie, one line lies on top of the other line. So that's for 2. Looking at this again, I'm not quite sure what to do. I'll come back to you on that. But looking at this one over here, this is going to be x minus 2y plus 8 is equal to 0, so it's going to be minus 2y is equal to minus x minus 8. So y is equal to, you're going to divide through by minus 2, so minus divided by minus is positive, so it's going to be a half x plus 4. So that's the 1. And then you've got over here y, you've got minus y, and I'm going to take that over to the other side, and it's going to be going to become positive. So you're going to have here, sorry, it's going to become negative a half x, and so y is equal to a half x. Now this, so that's that equation over here. Now these two lines are actually parallel because their slopes are the same. You've got a half and a half, but the one is going through the y-axis at 4 and the other is going through the y-axis at 0. So because they're parallel, you're going to get a graph, one like going through 0 and the other one going through at 4. They're never going to meet. Parallel lines don't meet. So this one over here, there will be no intersection points. I'll get back to you on this one over here. Let me just have a look at that again a little bit later. Question 11 is a long question, so let's have a look at that. It says, this is the plan of a village. Line L1 is that and line L2 is that. Represent the only two roads in the area. On both axes, 1 unit represents 1 kilometer. Family Alvarez live at A and there is a mall at M. Find the coordinates of the point of intersection of the road. So we want to find there, this point of intersection. Now we could just read it off here, I suppose. It looks like it's quite an accurate diagram, so I would think that just reading it off would be fine. 4 and minus 1 would be your coordinates of intersection. If you had to show that by means algebraically, you would just take your y is equal to minus x plus 3 and your y is equal to x minus 5, and you could just put the two together. And let me just do for the x and see if we can just check it up. I'd put, because both are equal to y, we can say that this is equal to this. So x minus 5 is equal to minus x plus 3. So I'm going to take that over to that side. It's going to become 2x is equal to 8, x is equal to 4. So there I've got that. And obviously I just put that into either one of these and I can get my y. Okay, so we've got that over there. Calculate the distance that family Alvarez have to drive each time they go to the mall. So we actually want to calculate this distance over here from A to P and P to M. Now there's actually two triangles over there. We're going to need to use Pythagoras for this, so we can use our formula. We can also use Pythagoras. I just like to work it out. This is going from 5 to negative 1, so that's 6, and this is going from minus 2 to 4, so that's also going to be 6. So this distance here, L1, that distance over there, let's call that D1, is going to equal the square root of 6 squared plus 6 squared. And we can calculate that out. So that's going to be 36 plus 36 is going to be the square root of 72. We are told that every unit is 1 kilometer, so that will be the square root of 72 kilometers. Looking at the other side of it here, we go from there to there, and so this would be D2. And here I'm going from 4 to 7, so that's 3, and I'm going from minus 1 to 2, so that's 3. So D2 will equal the square root of 3 squared plus 3 squared, so it's going to be 9 plus 9 to be the square root of 18 kilometers. And we can work that out. So we're going to get the square root of 72 plus the square root, actually, let me just do that again, square root of 72 plus the square root of 18, and I get the total distance is about 12.73 kilometers they would have to drive. Okay, you could obviously use the formula that d1 is equal to the square root of x2 minus x1 squared plus y2 minus y1 squared, as given in your data booklet. Then we need to show that L1 and L2 are perpendicular lines. So to do that, we need to show that if this is M1 and this is M2, we need to show that this formula M1 is equal to minus 1 over M2 is true. Therefore, M1 times M2 is equal to negative 1. So my slope of M1, I'm going down 6 and I'm going across 6, so that's going to be minus 6 and 6. That's going to be minus 6 divided by 6. Your slope, remember, is equal to your change in y over your change in x. So it's going to be negative 1. So M1 is equal to negative 1. Here we're going across 3 and up 3, so it's 3 and 3. 3 over 3 is 1, so it's minus 1 times 1 is indeed negative 1. So indeed these do cross each other at 90 degrees. For question D, a school S is located on L2. P is exactly halfway between M and S. Find the coordinates of S. Alright, so we've got a school S is located on L2, and this P is exactly halfway between M and S. So the school is somewhere here, somewhere there, and this distance from there to there is actually exactly half. So there's a number of ways that you can do this. Probably the easiest way, if I look at it, you have gone down 3 there. Now obviously you're going to need to go down 3 here and across 3 to get to this one. If that distance there, if this distance over here is equal to that, so if this is for negative 1, then you've got to go down a further 3, so that's going to be your y is going to be negative 4, and your x is going to be at 1. You would be at negative 4 and 1. Okay. And then E, calculate the area enclosed by MPA. So we have got our, we want to work out the area that is enclosed by MPA. So this area here, that area there. So to do that, remember we've got that this length here we've already worked out is the square root, I think it was, of 72, was it not? And this this length here, that length, so we called it D1, and this is D2, was the square root of 18. I think that's what we got. This would be a right angle triangle, so we just use our area is equal to half the base times the height. So it's going to be a half times the base, which is the square root of 18, times by the square root of 72, and we'll work it out. So let's just do that. So it's going to be 0.5 times by the square root of 18, and then we're going to times that by the square root of 72, and I'm going to get 18, and that will be the unit squared will be kilometers squared. Okay, so that was question 11.